Natural deduction negation. The deduction methods we have so far learned are so-called direct deductions. That is, deductions in which we start from given assumptions and derive step by step to the desired conclusion. We have also learned the method of proof by cases, that is, the use of the disjunction elimination rule. Now we learn to prove negated statements. The basic idea behind proving the negation of A is to derive contradiction from A. In other words, we take A as a temporary assumption and derive a contradiction B and not B for some formula B. The formula B can in principle be A, but it is more likely to be something else. When we have derived a contradiction B and not B from the temporary assumption A, we consider negation A proved. At the same time, the temporary assumption A can be eliminated. Let us try to understand the idea of proving a negated sentence. In all simplicity, it is the following idea. Suppose I come into a house from outside and make the statement that it is not raining. Someone may doubt and ask for a quote proof, unquote. I can say, look, if it rained, my coat would be wet, but my coat is completely dry, so it cannot be raining outside. So we accept the negation of it is raining because the sentence it is raining would lead to a contradiction with what we can clearly see with our own eyes. For another example, let us see why it is easy to accept the negation of, quote, the earth is flat, unquote. If the earth was flat, the shadow of the earth on the moon in a lunar eclipse would not be round, at least not always. But anyone who has observed a lunar eclipse has seen that the shadow of the earth on the moon is round. Also, people on long-distance flights, as well as captains of long-distance ocean ships, would observe, quote, coming to the edge of the world, unquote, type phenomena. But what they actually observe is that the horizon is always equally far away, and very distant objects seem to be partially behind the horizon, as if the earth was everywhere equally round. So the assumption that the earth is flat leads to conclusions that defy known observed facts. So we accept the negation of, quote, the earth is flat, unquote, as true. The point of these examples, and there are of course many more, is that in everyday language we accept negation of a statement if the statement leads to an absurdity. This is why also in natural deduction we prove negation A by assuming A and deriving a contradiction. Let us practice deriving a contradiction from given assumptions. We derive a contradiction from left parenthesis A implies B, right parenthesis, and A and not B. Intuitively, we have a contradiction because from A implies B and A we get B. And on the other hand, we assume not B, so we get the contradiction B and not B. So in the natural deduction, we first derive A implies B from the assumption by means of the conjunction elimination rule. Then we also derive A from the assumption by means of two applications of the conjunction elimination rule. Then we apply the implication elimination rule to A implies B and A, obtaining B. Finally, we get not B from the assumption again by means of the conjunction elimination rule. So an application of the conjunction introduction rule finishes the deduction of the contradiction B and not B from the given assumption. The rule for negation introduction is now this. The negation introduction rule. We assume A as a temporary assumption, derive some contradiction B and not B, and conclude not A, and at the same time eliminate the temporary assumption A. We learned above how to derive a contradiction from left parenthesis A implies B, right parenthesis, and A and not B. With the negation introduction rule, we can now write down a deduction for negation left parenthesis A implies B, right parenthesis, and A and not B, right parenthesis, without any assumptions. We simply take A implies B and A and not B as a temporary assumption. Repeat the above derivation of B and not B from the given assumption. Then use negation introduction rule to derive the negation of the assumption, and at the same time the temporary assumption is eliminated, indeed in 3 places. The deduction of negation left parenthesis A implies B, right parenthesis, and A and not B, right parenthesis, is ready. Let us then look at the derivation of negation A from A. This is perhaps a little difficult derivation because the derivation is very short and it may be difficult to see what is going on. The rough idea is the following. We assume A and want to show that negation A leads to a contradiction. Well, of course it leads to a contradiction because it blatantly contradicts the assumption A. So let us write down this natural deduction. We make the temporary assumption negation A and get immediately A and not A by conjunction introduction rule. So now we have derived a contradiction and we can use the negation introduction rule to derive not A, eliminating at the same time the temporary assumption not A. We are done.